I understand if this is not an option, but I did my homework on two separate pieces of paper. And
Okay.
I have like the first sum.
Okay.
Can I turn this half in now and bring the next half next class, or?
Just email it to me.
Okay. I appreciate it.
Yeah.
Let me write my name.
Good morning, Fayetteville High School. It is Monday, February 9th, 2023. Join me for the America Flag.
Mike's. Okay, I guess that is it for the minute of silence. I'm not sure what happened there. But if you did not turn in 59 and 60 in the Google Classroom, now is your chance to still get full points for it. So make sure your name is on each of those. 59 was the book assignment and 60 was the practice quiz. You will need a calculator for today's quiz, but everything else needs to be put away. Phones and smartwatches need to be turned in to the front of the room, please. Go ahead and start as you get it. All of the formulas that I promised you didn't have to memorize are on the top of the front page. So, even if you think you have them memorized, please double check and confirm. It didn't happen much, but I can tell you there was once last period where somebody lost a couple points because they used an incorrect formula. So, I mean, I don't know. It's literally printed for you on the front of the top of the front page. But if you're not careful, then I guess you could still miss it for that reason. I think it's pretty straightforward. Question 1 wants to know whether you should be using law of sines or law of cosines. I will point out questions 2 through 6 not only want the answer, but the directions specifically ask you for the formulas with the numbers plugged in. So basically, what are you putting in the calculator? So you should be showing that anyway for partial credit, but the way those directions say, that's where half of the points come from. So under some extreme circumstance, if you felt comfortable enough, you could go straight to your calculator, straight to the answer. Make sure you're at least writing down what goes in the calculator so that you're not losing those other 2 points. 2 points per question. And finally, I do have a couple handouts for you guys to pick up at the front of the room when you turn your quiz in and take your phone back up. Sorry, I thought we were still waiting for one more quiz, but I guess we have them. So I do have those graded and in the grade book, but like last semester, you will need to wait for them to be made up before you come and look at yours personally during advisory. Also, I had mentioned before the quiz that there's 2 handouts that you will need. It won't take more than 10 minutes to go over both of them, but if you did not pick those up when you turned your quiz in, I need you to go get those. And again, one more time, with the law of sines, law of cosines, we really just do that for you guys to help you on the ACT stuff. So there is no test with this one. You know, for your own sake, if there was something that you felt like you didn't quite fully grasp, or you know, something that you wish you had looked over before the quiz this morning, consider making yourself a note or two about that so that that will pay off for you on the ACT. But since we don't have a test with this one, if there was any assignments that you didn't complete or you didn't turn in at all, I will still give half credit if you do finish those and get them to me by Wednesday, because normally I would let you have until the test, but there is no test on this one. So if you didn't get full credit or you got a 0, please make sure that you make that up if you want those homework points back. Okay, what we will be spending the next few weeks on is something called limits. And so from today, we're going to look at probably the easiest question type when you have either a graph or a table. But the purpose of us doing limits is for a few different things. One is it gives you a tiny bit of insight to what calculus is like. And also, whether you choose to take calculus next year in college or in high school as AB, or maybe 5 years from now you change your mind and you end up taking calculus then. Regardless, limits are always going to be the first unit that you do in calculus. Calculus really only has 3 big topics. It's got integration, derivatives, and limits. And integration is really just the opposite of derivatives, and you can't take a derivative without knowing and using limits. So all calculus classes have to start off with limits. So when you eventually take calculus, unless you just decide never to do that, this should also make it a little bit easier the first few days or first couple weeks, depending on if you take it at high school or university. But there are 3 types of questions that come up with limits. This one only has one of them on here, but we're still going to have to consider the others. So really the only notes I need you to jot down here, we need to understand what this is, how this reads. There's 3 of them that look very similar. So these questions will read, what's the limit as x approaches, and then we'll usually put some number here. So I'm just going to make up a number just to make an easy example. What's the limit as x approaches 3 of f of x? Now sometimes there's going to be a little minus sign that looks like a little exponent on the 3. This means from the left. Sometimes there's a plus sign, which means from the right. And if there's not a plus or a minus, it has to be both from left and right. Now, the reason why I said that these are some of the easier questions, because a lot of times you don't know what a function's graph looks like. You don't have a graph, you don't have a calculator. So there's other stuff that you have to do in order to find a limit. But this is a good kind of introduction to it because it helps reinforce what a limit is and what you're trying to find. So what we'll be doing for the next few weeks when we find these answers, what it represents is what I'm about to show you. Okay, so for this first one, I've got some graph of f here, and notice this doesn't say from the left or from the right, but for at least this first question, go ahead and write down from the left and from the right, because when it doesn't have a direction like this one does, it's got to be the same from the left and from the right. Now, what a limit is asking, limit is a very easy concept. All it is asking is what y value is this f of x approaching as x approaches this x value. So if I want to approach 3 from the left, here's where x equals 3. I'm really just interested in this tiny little part of the graph that I'm highlighting. From the left means that you're taking an x value slightly less than 3 and moving it closer. And so as x approaches 3 from the left, the y value that it approaches is -4. So the limit is, all it means is what y value is it approaching as x approaches that x value. From the right, 3 from the right, you would need to take a number slightly bigger than 3 and then move it back towards 3 and then look at what y value it's approaching. It's also approaching -4 from the right, and if it's approaching the same thing from the left and from the right, then that is what the limit is. Limit is just what y value is it approaching. And for it to not have directions on it, it has to approach the same number from the left or the right. Otherwise, we say that it does not exist. Okay, now the biggest, I guess let's just go down to question 2. The most common problem that students have with this is you have to shake off, this is not anything to do with points. Limits could care less what's happening at x equals 5. X equals 5 doesn't even exist. There's a hole there. Limits only care about what's it approaching from the left, what y value is it approaching from the left, what y value is it approaching from the right, and if those two numbers are the same, that y value that it's approaching is the limit. Whether the point exists there or not, doesn't matter. Limits don't have anything to do with points. Okay, let me say that a couple more times and then we'll look at one with a table. And I'm going to have you try a couple of these before we're done today. So the limit as x approaches 0. So I'm interested in just this part of the graph when x is close to 0. So you have to ask yourself, what's it approaching it from the left? What's it approaching from the right? And from the left, it's approaching a y value of 2. From the right, it's getting closer to a y value of 2. And if it's approaching the same thing from the left and the right, then that's what the limit is. That limit is 2. Okay, and then again, on this one, I'm just trying to emphasize this because I don't know why students are always super attached to this, but just like the last question, there's a hole here. But notice this one actually has a point way down here. That doesn't mean the limit's -7. This graph isn't getting close to -7. This isn't getting close to -7. It's getting close to 2. Limits do not care what's happening at that instant. Just what is it approaching as you get close to it. Okay, so as x approaches -1, what would you think the limit of this would be? -3. Gets closer to -3 from the left, closer to -3 from the right, and if it approaches the same thing on the left and the right, that's the limit. Okay, and I think you got to turn your page maybe, but same idea, but instead of a graph, we've got a table, but it's really the same approach. It's just that you guys are less used to tables, I guess. But if I wanted to know the limit as x approaches -2, that would be like right in here. Notice I don't know what y is when x is -2, nor do I care. Limits don't care what's happening at that instant. It cares what's happening to the left. So from the left would be when the x values are a little bit smaller but getting closer to -2. I care about the right. So when x values, or sorry, I said that backwards. This is from the right, this would be from the left. The left would be a number a little bit smaller than -2, but approaches -2. And so what I'm looking at is this right here. It looks like from the left, the y values are getting closer to 8, and from the right, the y values are getting closer to 8. So a reasonable estimate would be that that limit is 8. Now, we don't really know for sure. Something crazy could happen between those 2 points, but probably not. Okay, so I would like you to try 6 and 7. So try with this table, see what you get. And number 7 to try one graph before we go over it. We'll go over all of them together, but I'd like you to try a few of them before I say it out loud to see if it's really sinking in for you. Okay, so for the table, again, you got to think about what's happening as x gets closer to 1. So as x gets closer to 1 from the left, it looks like the y value is getting closer to 6. But you also have to test from the right. So as the x value gets closer to 1 from the right side, -6. It looks like this is getting closer to -6 as well. And if it's approaching the same thing from the left and from the right, then that's what the limit would be. And then number 7, these are not spaced out great, but what do you guys think that the limit might be for number 7? We haven't seen one like this, so I'm just giving you a chance to throw out a guess. Right, so limits aren't going to have two answers. If it's approaching one thing from the left and something else from the right, that limit does not exist. There is no limit there. It's not approaching a y value as x approaches 4. It's approaching two different things. So number 7 was a little bit of a trick question. If it's approaching something different from left and right, we say that that limit does not exist. You can just abbreviate D&E. And again, I didn't space these out very well, but you'll get more practice on this another day. We're going to just kind of add to this a little bit each day. But question 8, let's go ahead and knock the rest of them out. As x approaches 0, well, it's approaching 5 from the left and -5 from the right, but it's not approaching the same thing on both directions, so he doesn't have a limit. At least not as x approaches 0. -4 looks like the same problem. It's approaching some number on the left, some number on the right. I don't even care what it is. If it's not approaching the same thing, then that limit cannot exist. Okay, and then finally, or next to last, the last one you have to be a little creative on. As x approaches -5 would be right here. And again, unfortunately, it's approaching a different number from the left and the right, so that limit does not exist. Again, I probably should have scrambled these questions up a little bit better, but if it approaches the same y value from the left and the right, that y value is the limit. If it approaches a different number on the left and the right, then that limit does not exist. Okay, and then last one I want you to try, and then we will be done for today. Here's one where it's kind of backwards. So here's g of x. It's telling you the limit is 3, and it's asking you what could x be approaching to have a limit of 3. So I want you to try that one before we discuss it. Okay. I think there's 3 different answers you could come up with here that would work. It looks like it's approaching a y value of 3 right about here from the left and the right when x is 2. So that's probably the most common answer. But technically, about right here as well. From the left it's approaching 3, from the right it's approaching 3, and that looks like at about 4.5. So if you estimated 4.5, that looks like he also has a limit of 3. And then way over here, there's even one more possibility. It approaches 3 from the left and 3 from the right when x is about -8.5. So any one of those would be fine. I think most people just usually pick 2 just because it's the only one that's a nice whole number. But so again, let's just try to give you an introduction to what a limit is, and when we're finding limits, what we're describing, and just a little bit of practice from reading it from the graph. So, should be a pretty easy first day for that. But like all of our handouts, if you feel like you need to summarize that in words to yourself or highlight something in that that's not super clear for you, then please do that before you put it up. Otherwise, we will continue on that topic again on Wednesday and for the next couple weeks. So.